let's simulate the dynamic rolling resistance coefficient. So we have seen that the coefficient is constant, but it depends upon the speed and the tire pressure, so that we can use this equation, and by using this equation, instead of constant, we can add the dynamic rolling resistance, such that by changing the tire pressure and the speed in km/h, we can change the constant of rolling resistance in the Simulink model itself. So this equation start with the two variable velocity v and the pressure rho. So start with the v, the speed in km/h we can attach at this point, and it is divided by 100. So I have used the divide block. It is available in mathematical block of the commonly available block. So divide by 100 and then all square. So I have used the square block from the math operation. So we completed this equation, and it is multiplied by 0.0095. So use the product block and multiply by 0.0095, then summation block and added the 0.01 constant, and output of the summation is added to constant 0.05. So this point, instead of constant c, now we can connect it to this point. So now the rolling resistance is not constant, but depend upon the rho, which is currently 2.9 bar, and speed will be depend upon our simulation. So starting it will be 0, and as speed increase, our rolling resistance coefficient will also be changed. We can add one display also to have the final rolling resistance coefficient, so that we can have idea about it. And when we run the simulation, we can say its value come to the 0.01 with the speed 84.34. If we increase the pressure 3.5 bar and now again simulate it, so we can say it comes to 0.098. So this way we can add the coefficient of rolling resistance and its dynamic value with the simulation. So now you know that any kinds of mathematical equation can be easily added in the simulation to have its effect. So now by using this simulation model, you can do lots of experiment and take a result. So this is how to add dynamic rolling resistance coefficient in the vehicle simulation model.